To measure the resistance or impedance of a load, multimeters often use a technique known as constant current. In this method, a source current of constant known amperage flows across the load under test. The multimeter simultaneously measures the voltage across the load and employs Ohm's law to calculate the resistance. A relatively simple setup for constant current and resistance measurements is the two-wire method, also called the two-probe method. This entails connecting two probes to the load under measurement, running a known current through the load and measuring the resulting voltage, and then calculating the resistance. In the diagram shown on the screen, the probes numbered 1 and 2 provide constant current to the load under test, and also measure the voltage across the load in order to determine the resistance. The two-wire method works well for moderate to high load resistance or impedance. However, for very low load resistances, the resistance inherent in the probe wiring and contacts can contribute a significant percentage to the overall results, making the measurement of the test load resistance inaccurate. To accommodate this issue, more advanced instruments employ a setup known as the four-wire or Kelvin method. As the name implies, this involves using 4 probes in an arrangement similar to the example shown on the screen. In this setup, 2 separate pairs of probes are used. Pair 1 and 2, sometimes referred to as the source probes, provide a known quantity of constant current, as in the two-wire setup. In addition, the Kelvin technique employs a second pair of probes, labeled 3 and 4 on the screen, to sense voltage. The second pair is often called the sense probes. The placement of these probes ensures that only the voltage across the load is measured, independent of any resistance contributed by the current or source probes. There is virtually no current flowing through the sense probes. Nearly all the current flows through the source probes. This allows for a high level of measurement sensitivity and accuracy when the load under test is of low resistance. The ability to accurately measure low resistances can be critical in applications that involve high current, since even a small change in resistance, for example due to fluctuating temperature, can have a significant effect on voltage levels. AEMC Instruments offers a family of micro-ohmmeters capable of performing four-wire measurements for load resistance and impedance. This includes the recently announced micro-ohmmeter model 6292. In the example shown on the screen, the model 6292 is measuring the resistance of a test shunt. Other AEMC micro-ohmmeter instruments that provide four-wire testing include the model 6240 and model 6250. Note that the four-wire method is not suitable for all applications. For example, when the load resistance is high, the resistance in the probes is relatively smaller as a percentage of the overall resistance, and therefore does not introduce an unacceptable margin of error. Further, measuring high resistance loads requires that the constant current be kept at very low levels. As a result, ground leakage resistance can become a significant contributor to the overall resistance measurement, in the process rendering the measurement inaccurate. The model 6292 mitigates the problem of ground leakage by offering a mode called both sides grounded, or BSG mode. In this mode, the model 6292 uses an external DC current probe to measure and eliminate ground leakage current from the total test current. We hope you have found our brief explanation of the four-wire Kelvin method helpful.
For more information, please visit Technical.